Okay, so to do problem 1 on this worksheet, what you guys should have done was figured out the number of heads required for 50-50. So if you're flipping the coin only 10 times, to get 50-50 you would need 5 heads. And if you look here at the Fathom output, 5 heads occurred 24 times. And since we did it a total of 100 times, that means that the probability is 0.24. The next graph and table show what happens when I flip the coin 50 times. And so if I want a 50-50 split on heads and tails, that would mean I would have to get 25. 25 happened 6 times, and so then that probability would be 0.06. Finally, if you flip the coin 100 times, and we're looking for a 50-50 split between heads and tails, that would mean 50 heads. That happened 7 times. So that probability is 0.07. Okay. So what happened here is the same thing that we saw before. If you are placing a bet and you're trying to get an exact 50-50 match, then you want to have to flip the coin a smaller amount of times than a larger number of times to be more likely for the exact 50-50 split to occur. Okay, so next we're looking at what happens with extreme values, so less than 10% or less heads, or 90% or more heads. So 10% of 10 is 1, so that would mean that we would have 1 or 0 would be 10% or less, and so that happened 2 times. And then if I went 90% or more, 90% of 10 is 9, so that means 9 or 10. And so if I look up here, I only had 1 10 and no 9, so the probability of a really extreme event is defined as 10% or less, or 90% or more would be 0.03. If you flip it 50 times and you're looking for 10% or less, well, 10% of 50 is 5, so that would mean the numbers 0 through 5 would be an extreme event, and that never happened here. So that didn't happen, so I'm going to put a 0. If I want 90% of 50, that's 45. So that means that 45 to 50 would be extreme events on the high side. And if we look up here, that never happened. So based on my simulation, the probability of a really extreme event is 0. Finally, if I flip it 100 times, 10% of 100 is 10, so that means 0 through 10 would be an extreme event. Never happened. And 90% of 100 is 90, so that means 90 through 100 would be extreme events on the high side. Never happened. And so the probability of an extreme event is 0. So again, just like we've seen in the book, if you're looking for an extreme value to occur, that's more likely to happen with a small sample size than with a large sample size. Okay. So finally, we're going to look at what if we're just trying to get close. So an empirical probability between 45 and 55% is how I'm going to define close this time. Because the true probability of getting ahead when you toss a coin is 0.5, so that's halfway between 45% and 55%. All right, so the first calculation I did was I took 45% of 10, and I took 55% of 10. So that means that the number of heads that are possible to get to be close is between 4.5 and 5.5 when you flip a coin 10 times. So in here, that just means 5. So I want 5 to be close. That happened 24 times, so my probability of close, if I flip it 10 times, is 0.24. Now if I flip it 50 times, and I just want to be close, 45% of 50 is 22.5. 55% of 50 is 27.5. So the number of heads that are possible to get to be close is between 22.5 and 27.5. So that means 23 to 27 is what we're looking for. Okay, and if you add those up, you have 13 plus 10 plus 6 plus 13 plus 13. That's 55. So the probability of being close when I flipped it 50 times is 55%. So now if I go even larger and do a sample, flip the coin 100 times and want to be close to the true probability of 0.5, that means 45% of 100 is 45 and 55% of 100 is 55. So I need to be between 45 and 55. So the number of times that close occurred if I add up all of these counts, the 2, 6, 6, 10, 6, 7, 12, 1, 7, 9, 4, that occurred 70 times. All right, and so my probability of being close with a sample of size 100 is 0.7. So you can see that if you want to be close, the bigger sample size is better. So to summarize, if your goal is to get an exact 50-50 split, should you flip the coin a small number of times or a large number of times? You should flip it a small number of times. If your goal is to get a really extreme value, should you flip the coin a small number of times or a large number of times? We saw in problem 2 that that should be a small number of times as well. And then finally, if your goal is to get a proportion that's close to the true value, should you flip the coin a small number of times or a large number of times? That's when you want to do it a large number of times.